I can always change it. Alexa, Amazon 配達読んでください。Hey, good morning. This is another daily learning exercise where I'm going to go ahead and go through the algebra basics. And today's algebra basics is order of operations, aka is PEMDAS. Yesterday I was moving through square roots. I finally finished that section over there, and the idea is to understand the idea of learning how to learn and moving through new ways of understanding things for the sake of building a new skill. I actually spend about maybe I would say 7 to 8. I spend about maybe like 7 to 8 hours a week, working on my skills that I'm basically trying to do on a regular basis. And honestly, it's pretty amazing how much you can get done doing a little bit every single day. One of the things that I find that is actually interesting about learning something new every day is the fact that that what you learned the day before is like retained and you can use it the next day. So for example, I had some holes inside my arithmetic. I would can do basic arithmetic in my head and algebra, equations. But one of the reasons why I would always have to do the work because of the fact that I had to have had some class work I had to go get done, or there was some tests I was basically about to take, and that was the only reason why I was motivated getting the work done. And then it made the whole idea of working very, I guess, uncomfortable because of the fact that I was only trying to do the work to get it done to do something else. So I wasn't in the present moment of actually learning something new. And I think that that's one of the secrets that you need to do in order to learn something new. Try getting up a little bit earlier. Try to find ways to motivate yourself doing certain things. Like for me right now, I have this big plan to go into graduate school. Taking these advanced classes in computer science and computer engineering. And these larger dreams are very bigger, but much larger than myself. And it becomes very interesting when you are trying to learn something new, how well you can move forward just by not trying to force yourself. So, for example, if math is not your thing, but you are interested in anything, where you have to, probably have to make something, like engineering, you probably would want to, get better with your math. If you're looking to start a new job and you want to go to school and you don't want to go to school, or you're not confident going to school, there's a lot of courses online that can prep you for school before you even walk in the door. And I think it's great. I think that that's important to kind of sharpen your skills like that. I also work out in the morning too, to make sure that I have my body is, working at the highest level that it possibly can. And trust me, it's not easy, meaning that it does take some time for your mind to move through it. But try to do something where you are gamifying your daily routines in such a way that the phone that you're using, for example, or your computer, or any devices that you're using is retaining this journey that you're on. So you'll always know how far you've come, and you'll probably be able to predict where you're going to go. So not talking too much, further, I'm just going to go ahead and just start today's today's lessons, which is basically the order of operations. So if you are familiar, I think I am sharing the screen right now. Order of operations, they don't really show order of operations right away, but here on KhanAcademy, they give you like examples. I just want to look at the order of operations. So from where I remember it, I always started using this term called PEMDAS, which basically stands for like, please excuse my dear Aunt Sally. And this was exactly the way I learned it in school. It was weird because of the fact that the terms was not necessarily easily, it wasn't easily expressed when I was in school. Like, these were like acronyms we used to memorize it. And once again, I was learning these things because I was trying to go ahead and just, take a class and be done with it. I didn't have like any larger passion than getting it done. So when I had that mindset, it always forced me to, how would you say it? It would always force me to have to work harder. I felt it was kind of like I was like driving my car with the emergency brake on. You were working harder than you actually need to do, and it was more and being able to drive, my car with, for example, without that emergency brake on is how I'm acting right now, where I can just slowly it takes the same amount it takes a little bit less work because I want to do it. But as I continue to do it, I have this momentum, So I don't want to rant on too much. I'm just trying to, explain these things. So basically, this is the terms that we use. And this term was an acronym for the words parentheses, exponents, multiplication, division, addition, and subtraction. And the idea was to you would start here with anything that's in the parentheses. If there's nothing in the parentheses, you move to exponents. And then you do anything that's in exponents. And then after that, you move to mass multiplication, then division, then addition, then subtraction. So subtraction is usually the last thing you would do, and parentheses is usually the first thing you do. And you always have to do it in this order. After a while, you get used to it. But if you're using programming, you can play around with your programming arithmetic, and you can see it being done there too. So let's go ahead and move forward here. So we have 10 to the 7th power. Since we have 10, we just know we can just probably could just add 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. Yeah, I think that's it. So 10 to the 7th power is literally just 10. Yeah, 6, 7. Oh, it's 8. All right, so I gotta go ahead. So it's 10 million. So 4, 5, 6, 7. Yeah, so it's 1, 2. So 10 to the 1st would be 10, and this is 100. Yeah, and that's how I continue to add the zeros that way. All right, so we know we have that's 10 million. Next one is 9. So this 9 over here can get placed in this little corner here. And then we have 3. I mean, 1 to the third. So we know anything times 1. And 1 to any power is always going to be 1. So we know we can just add one more there. So we have that. So it would be 10 million 10. 4 5 6 7. Yeah. 1 2. Yeah. 1 2 3 4 5 6 7 8 9. I think I'm actually 1 0 off. That should be it. Okay. All right. So let's move on to the next one. All right. So now we have 6 squared minus 6. And it says order the operations from least to greatest. So we could, in this program, in this example, I can go ahead and I can take 6 squared minus 6, or 5 squared, or 4 squared plus 2 squared. We know already that anything times squared and if you add 2 numbers to the square and square them, that's going to be really large. So we can move that one up here without even having to actually do the math. The next thing is that we have the subtraction here, right? So this is going to be really tricky because of the fact that we have 6 squared. That's 6 squared. 6 squared is 36 minus 6, which is 30, right? But then in this one is 25. The reason why I still would do it is because I'm thinking about 7 squared minus 7. So 7 squared would be 49, and then 49 minus 7 would be 42. And then if you had 6, so it's okay. I think that's good. I could see that. So this is basically the least. This is least to greatest would be here. This is least to greatest. Oh. Order the expressions from least to greatest. Okay, so this is 16, and this is 4, and that makes it 20. Look at that. Yeah, messed up. So that basically tells me that I have to go ahead and do this. Like, I have to always go through it as well. So this is 20, this is 25, and this is 36 minus 6 equals 30. So let me just make sure I write it. So this is 20, this is 25, and this is 30. Because 36 minus 6 is 30. Yeah. 20, 25, 30. Okay. Okay. Yeah. All right. Do you have the next one? You have this one here. It says 10 plus 5 cubed minus 1. So this is pretty much 5 times 5 will be 25. 25 times 5 is 125, right? And you have this, let's see, it's 10 minus 1, and that's 135. And then minus 1 is just 134. So you always do the exponents first. So we should be able to get that exponent. Okay. Next one is, this one we have here, we have 8, 8, 8. So this times 8 is 64. And then this times 8 is really big. I don't remember how to, I don't want to do it in my head. So I know 8 times 3 is 24. So 8 times 6 is 48. And then you have 48 plus 8, which would be 56. Because that's just like 8 times 7. So then we would have that. So we would have 5. This is actually 562. And then we have minus 9. Right? And then we have times 2. And then we have divided by 3. And if we go to our, PEMDAS, we don't have any parentheses in here. We just did the exponents. So next thing would be multiplication. So we want to go ahead and do this. So this is like -9 times 2, which means -18. And then we can bring the 562 down here. And then we have this negative divided by 3. So that'd be division. So we could do division next. So 18 divided by 3 is just like saying, what do you call it again? Like this. And we would get -6, because the reason why I knew it, because negative times a positive is always a negative. So since this is a negative, we have to be a negative right here. So that would leave us there. All right. And then we have 562 minus 6. That would basically be I can't think of it. It's 50 is 4, and then we have 556, because that would be 556. So 556. No. All right, I messed up. So 552 minus 6. Right, you take 1. This will be 5. Yeah. Okay, that's right. Maybe I did something wrong. Did I really this properly? 8 times 8 is 64. 8 times 8 is 64. Why am I? Yeah. Okay. And then 8 times 3 is 512. Oh my God. I actually did this wrong. So that's 512. So now we do 512 minus 6, which would leave us with 506. Oh my God. Yeah. See? Yeah. Messed up. That's one thing reason why I usually check my work as I go along, but it's okay. Okay. So next thing is we have is 2 to the third minus 2 to the first. And that's like 2 here. And this is 2 times 2 times 2, which is 8. Right? And then you have, let me see. Now we have that as 6. We have the next one here is 3 to the 3, 6, which means 9. And this is 2 plus 3, which is 5. Okay. So then you have 5, 6, and 9. So we would actually have this one go first. And this is second. Now it looks all confusing because I have all the numbers at the top. Let me just put that. Okay. And then you have 5. This is 5, 6, and 9. Yeah, that's right. Okay. Okay, so next we have this other one. We gotta remember the idea of PEMDAS, right? Which is, please excuse my dear Aunt Sally. We don't have any parentheses here. We do have exponents. So we want to do exponent first. So let's go ahead and let's do the exponents first. Okay, so here you have what we had before. Remember that I said 8 cubed, or 8 to the third power, is 512. Something I could start remembering again. And then we can divide that by 2, right? Because once we go ahead and we have, we do the exponents, if there's no multiplications, we do division next. So 512 and a half, it's going to be pretty much, what do you call it again? 2 to 12 is 6, and there's 2, 3, 3. I think it's 256. Yeah. And then because what it is what I did is I divided 50 and then I divided 12. That's the idea right there. Okay. Okay, so now we know that we have, now we know that we have 256 is this answer here. Now we can go here and we can add 9. And 9 plus 256, we add a 3, we get 259. We add 3 more and you get, oh my God, 256 plus 9. That's 3. Or I could just add a 4, bring that to 60, right? And then just add 3, so it'll be 263. Oh, I did something wrong. 264. 260. Why I can't? I'm trying to. Okay, I go ahead and what I do is that I have 256 right here, and I want to add 9. So what I do is I just say, oh, this is 256, right? It's like what would make this 260 really quick? 4. So I take 4 from here, and I will make it 260, and then you end up with 265. I know that I feel like I don't know why, but I feel like that breaking down the numbers like that is probably better. But what I need to start doing is maybe writing it down as I do it, and not trying to do too much things in my head. Anyway, let's move to the next number. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 2 to the 8th power. We can remember that this is going to be 4. This is going to be 8. This is 16, 32. So that's 4, 8, 16, 32, 32. And then you have here is 64, and this is 128. And then here is 256, right? No, yeah. 128 was 128. Yeah, taught myself. Okay, so 256 minus 10 is 246. And then you have here is minus 15. And that's going to be something like 1, 3, 2, 6. Yeah. So, and then we have divided. Oh. See, I almost did something wrong just now. Once, I should always put PEMDAS on top. Casting PEMDAS. Okay. Then once we do this, we don't do the subtraction. The subtraction is the last thing to do. See, I almost made that mistake. And then you have here is divided by 3. So now we divide 15, negative 15 by 3, not negative 256. It's going to be negative 5. So now we have this. Now that this, well, actually this goes to that. Now we can put the negative 10 down here and the 256. And then the next thing we would do is say negative 5, subtract negative 5. That's like saying I have negative 5 in my account, and I use my credit card, to buy something. Now I have negative 15 in the credit in the bank in account. So we have that, and we have 256. So what you do there is 1, and then you have 4, and then you have 2. Whoops, yeah, 241. See, and then you have 241. Yeah, that wasn't so bad. That was just actually my mistake right there. All right, I'm gonna go ahead and do that again. And you have match each expression to its exponential form, and it has exponent and then solution. So what's going on here is that We have, let's put it like that. Yeah. So we have three examples, three problems. Each problem is taking advantage of some sort of exponent inside the answer. And I mean, it's using exponent, a part of the number, to solve the problem, and the solutions are here. Each solution here is not lined up properly. So I have to start doing, I could do one or the other. I could go ahead and just try to guess it, but this is about trying to practice, doing these problems in my head. So you have four square, right? So you have 2, 2, 2, right? 2 times 2 times 2 times 2, which is, this is 4, this is 8, and this is 16. So this top one would be 16. And then the bottom also would be 16. And you can see right there where it's going, because you see these large numbers here, doesn't mean we're going to get a large number, but we actually get 1, because 16 over 16 is actually 1. So then the next one here is, you have 3 is 3, so and you have 2 times 3 would be 6. So that's actually correct. And then here you have 4 minus 2. 4 minus 2, which is 2, and 2 squared. So that's actually 4. So the answer would be down here like that. This will go here. So this is the answer. Okay. Next one we have is evaluate the following expression. Evaluate the following expression. And then you have here 40 times 8. And then you have 40 times 8. And it's 8 times 0 is 0. And then 8 times 4 is 3, 2, 20, 320. I shouldn't do this one first, but because there's only an exponent on this side, I'm going to do that. So so basically on this side, we're going to get, every 100, so I shouldn't have done that, but I like doing that one because that was the easiest one for me to do, and it doesn't really affect this number here. But anyway, I'm not going to talk too much about that right now. We have 320 minus 100, which is 220. And then you have here's 220. All right. Next one we have the same thing where it says evaluate the expression. Don't forget our PEMDAS rule. So we have 3, 4 3s. We have this is going to be 9, and we times it with 3 more. This is 27. We times it by 3 more. This is 70, 81. Yeah. I mean, let me times it myself, just making sure. 1, 2, 6, 7, 81. Yeah. Yeah. So it's 81. So we have 81, right? And 81 is here. And now you have 81 plus 9 plus 1 minus 9. And then you have, so that we do PEMDAS again, which is, this will be 90. And then you add one more, be plus 1, 91. And then you have add this one is 9 minus 1. So that would bring us back down. So we would have, I think it's 78, 72. Because if I add this right here, it's 81, 72. So that would mean that this is the answer 72. No, I think I'm actually missing one more thing. Yeah, once I do 81 plus 9, that's 1, subtracted 9. All right. 81. Let's do it the other way. I should do it from the left-hand side. So 9 minus 1 is 8. 8 plus 9 is 17. Then 17 here. Yeah. It's 8. It's 98. So that's 98. That's right. Next thing is match each expression to its exponential form. So we have 3 plus 5, right? Oh, wait, actually, let's do the exponential first. We know this is 125 from the last problem, you know. 5 times 5 is 25. If you times that by 5 one more time, it is 125. And then here we have 10 times 10 is 100, right? And if you divide that by 2, you get 50. And then here you have 3 plus 2 is 5, and 5 times 5 is 25. But they don't put that here. They actually give you this. So this is a great example of trying to show you, like, you know, that if I say 5 times 5 is equal to 25, or I could say 5 times 5 is equal to 5 squared. I can say that too. That's actually right too. I mean, another trick question is I could say 5 times 5 is equal to, you know, 50 minus 25. You know, I can say that too. That's also correct. And if you put this on your, try this, and if you have any tests or anything like that, and just to see if, you know, a teacher makes it wrong or something like that, but technically it's not wrong. That's the cool thing about math, is that you, you know, there's so many ways to get to the question. It's almost like programming. So, so there we go. So we have that is over there, and we have here it's 5 squared, right? And that's 50. And oh wait, 25. And then here's 50. So this should be the answer. Final answer. Let's see. All right, there we go. Okay, let's continue. All right, we have here, we have 3 times 3 times 3. We know that this is 27, but I'm just going to do it again. 3 times 3 is 9, times 3 more is 27, okay? And then we have minus 10 plus 7. So you have here 17 plus 7, and then that would be 14, all right? And then you carry the 1. My mind doesn't want to do that this morning. Yeah, 24. Okay, so once we do this first, because remember, PEMDAS, don't ever forget this, parentheses, exponents, multiplication, division, addition, subtraction. And what you're doing is you are trying to, go ahead and, you're trying to go ahead and, you're trying to do the exponents first, get that out of the way, then you focus on multiplication, then division, and so on. So since we have this, I think it's 24, right? 27 minus 10 plus 7, 24, yeah. Okay. All right, let's keep this up. I think I'm doing good on time. What's my time clock looking like right now? Sorry, 1 second. Just want to check. 8:43. Okay, yeah, I'm doing good. It would be, I'm like over, like, you know, but I had to spend some time doing it. All right, so great. This is evaluate the following expression, and it says here, you have 6 divided by 3, and then you have plus 9 squared minus 4. So what you're doing here is that this is going to be 81, right? Because 9 times 9 is equal to 81. And then we have here 81 minus 4, and we have here plus 3 divided by 6. So what's going on is that we will do the PEMDAS rule. And the PEMDAS rule is exponents first, which we did. Then, well, first was parentheses exponents, and multiplications next. We don't have any exponents, so we're gonna go division. There we have division here. So 6 minus 3 is pretty much 6 minus 3 like this. It leaves us with 2. Sorry, 2. Because 2 times 3 is 6. And then you have 6 plus 81. And then you have 87. And it's 87 minus 4. 84 7 is 83. Oh, I made a mistake. Oopsie. I said 87 times, so this is not supposed to be that. It's supposed to be 2. No, I'm actually right there. Hold on. All right. So I made a mistake. 81 minus 4, because I wasn't supposed to do this first. I'm supposed to do this. So let me go ahead and clean up this real quick to make my, so 6 divided by 3 is 2. Let's bring everything down. Down, 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 down. That's 4. All right. So what's going on here is that you have 2 plus 81. That's 83. And then you have minus 4. This would be where we're going to go to 79, I believe. Because I take one from here to make it even. Then I add whatever's left. And that's how I do it. I don't know. It's just less of a problem. So it's actually 79. Okay, here's the next one. Order the expressions from least to greatest. We have 8 is 64, because 8 times 8 is 64. And we minus by 60, right? Which would, right? And that would leave us to 4. So this is actually 4. And then we have here 2 times 2, 2, 2, 4, right? And 4 times 5 is 20. So this is 20. I'm sorry if I'm making, I know that I hate looking at Scribble Scrabble too. I don't want to Scribble Scrabble too much. All right, and then you have 11 to the first power, which is always going to be 11. So don't really pay too much attention to that. So we have here 4, 20, and 11. 4, 20, 11. So now we could put it in least to greatest. So this is 4 is smaller than 11. So 11 should go on this side. And then 20 is bigger than 11. So 11 should go this side. So it's going to be like that. And we can just go ahead and for our sake, we're going to go ahead and we're going to say 4, 11, and then 20 like that to make sure we get it right. And there we go. And we're making good progress. PEMDAS is actually a great, it's a great skill that you need to have. I look at this particular algebra basics as like the foundation of doing algebra equations. Algebra equations can be very sneaky if you if you don't go ahead and practice these small basic pieces on their own. Approaching pre-algebra can be overwhelming. Don't rush the process. Take your time and get through it, and take breaks, make sure that you're always taking breaks. Even like right now, I do these little things like 20, 30 minutes out of the day. That's great. I would probably in the morning, I usually start with the most challenging thing first, and then I work towards all the things else I have to do. If you have work, you can still get this done with work. You can still get this done doing other work that you're getting done. But if you're in high school or you're in college and you want to do, mathematics and things are getting rough for you, the best thing to do is to just spend time doing math, like simple math, the math that your mind doesn't have a problem playing around with for a while and then go back to what you used to do. I'm realizing, you know, each day that it's better to approach a complex problem instead of it being hard, meaning that there's a lot more simple problems that you have to break down and then work on each one. That's never really been taught to me, and it probably hasn't been taught to you. But I definitely feel that if you work on it this way, you will see success. Because this is what I'm trying to share, right? Really, I'm really trying to share these things and to not just help myself, but help other people see that it's possible. Putting my thoughts on the table and working through it. So anyway, thanks a lot, and I'll see you guys in the next video.